This is 8.2 part 3. We're going to finish question 2b. So this was 2a, we had finished that here. We're using our sine law to solve for, to try to find missing angles this time. So we're going to do another example where we have a triangle with some sides given to us and an angle, and then we're going to try to use our sine law to find the missing components. As per usual, if I were to ask you to solve the triangle completely, so if I were to say solve this triangle, you need to find everything. But in this case, we're just saying find the missing angle in each triangle. So in this case, we're looking for this here. So we're looking for x over here. I'm going to start off by naming my triangle components. So I'm going to have A over here, uppercase A, uppercase B, uppercase C. So this x would be really angle B. So x, in other words, is angle B, just as a reminder. Now I have two sides, but you'll notice that I don't have any angles, and that could be a problem usually, but you will see that there's an angle over here. This should be more continuous with the bottom over here. There's an angle here, 124. And what we know for sure is that 124 plus this angle over here is equal to 180, because they're supplementary angles. So let's go about and just name our sides again. So this is vertex A with angle A. This would be side A. This is vertex B with angle B. This would be side little b over here. This is vertex C with angle C. This would be side little c over here. And so we know that, so we need to find that angle there. We know that, let's call this angle C. So angle C plus 124 is equal to 180. What that means is that angle C is equal to 180 minus 124. And so we get 56 degrees. So we found angle C being 56 degrees. So now we have two sides and a known angle opposite to one of those sides. So now we can use the two sides and the known angle to find the unknown angle that we're looking for, which is x here. So since we're looking for an angle, remember that we want to start off by writing our sine law with the angles on top of the fraction sign and the sides below it, because we're looking for angles specifically. So I'm going to continue the work here for part B. So we know that sine of angle B, which is x, I'm just going to put x for now, but no, it's angle B. And actually what I'll do is I will put B just to be accurate with the way I'm writing my form here. So sine of B, which we know is actually x, just a reminder, over 112, because it's the opposite side of angle B, is equal to sine of angle C over 98, because 98 is the opposite side of angle C. And I'm going to write this first, actually, the formula out first, so let me do that before I actually plug in numbers. So sine of B over B, sine of C over C, which is going to be sine of x over B, which is 112, which is equal to sine of 56 over C, which is 98. Now I can solve by sending the 112 over to the other side. In other words, multiplying both sides by 112. 112 times sine x over 112 is equal to 112 times sine 56 over 98. Cross the 112 out here. I'll continue the work here. I get sine of x is equal to 112 sine 56 over 98. Now this is not my angle yet. This is just sine of x. To find my angle, I need to write x, that's my angle, is equal to the inverse sine of the 112 sine 56 over 98. and that should give me my angle. So I usually like to put this all in the calculator together, or I can find my answer and then put it in the calculator after, but I don't want to round too much, because if you round too much, your angle will be too far off. So let's say you're not doing it all together in a calculator, you're just trying to find the answer. So sine 56, make sure it's in degrees mode, times 112 equals, divided by 98 equals, I get 0.947471511. I'm going to leave that in my calculator. I'm going to push my second function, sine, that gives the inverse sine, and then push answer. Your calculator might be different. You can select to put the answer in there. And I get, if I round the 2 decimal places, 71.35 degrees as my x. So then you would make a therefore statement saying therefore angle x is 71.35 degrees. And so again, start off by writing your formula you're going to use. You didn't plug anything in yet. Then plug everything in where they need to be. And then solve for sine x, or sine of your angle, and then do the inverse sine, and you have your answer. So sometimes you will have to remember some of your angle rules, like complementary, supplementary angles, to find some angles within the triangles in order to do that. So practice doing that to build a habit. I did post a angle review sheet at the beginning of the unit, so please at the beginning of chapter 7. So please make sure that you go back and review that if you don't remember supplementary, complementary angles, and all those other patterns as well. It will help you greatly for this unit. So what we're going to do is we're going to start a sample problem that's a word problem now, and see how we can use the sine law to assist us in solving that word problem. So let's go ahead and take a look. We always want to do, when we do a word problem, we always want to sketch something out. If we sketch something out, it's a lot easier to see where things are coming from. So we have a chandelier that's suspended from a ceiling by 2 chains. One chain is 46 centimeters long and forms an angle of 60 degrees with the ceiling. The other chain is 64 centimeters long. What angle does the longer chain make with the ceiling? Round to 1 decimal place. So we want to start off by doing a sketch. So let's say we have our ceiling over here. And we're going to draw our first chain over here. So this is our ceiling. And it might go a little bit beyond the triangle, that's fine. This is our first chain. We'll make this 46 centimeters. And the angle it forms with the ceiling is 60 degrees. And we have another chain over here. Our chandelier is somewhere over here. We don't really have to draw it in, but this is our chandelier. Bad chandelier, but that's okay. And we want to know what angle this is. We know the length of this chain. I should have made it longer than the first one in my drawing. It should have been a bit more to scale, but it's not to scale. But I still have the right measurements there. And so we want to find this angle over here. So what do we have? Well, we have 2 sides and an angle opposite to one of those sides. So we have a situation here called side, side, angle. 2 sides and an angle opposite to one of those sides. So if I've identified side, side, angle, then typically that means I can use the sine law. So let's just label our triangle. Let's call this vertex A, B, and C. So X is angle C, 60 is angle A, 64 is side A, 46 is side C, little c. So we have a lot of information. We don't really need to know the length of the ceiling, but if we want to, that would be side B, little b, for this part of the triangle there. So we want to find an angle, so we're going to write our sine law with the angles on top. So we know that sine of angle C over little c, side C, is equal to sine of our known angle, which is angle A, over a known side, side A. And so now I can go and plug in numbers. Sine of angle C, which is x, is equal to, over length of side C, which is 46, is equal to sine of 60 over length of side A, which is 64. Now I can solve for sine x by multiplying both sides by 46, or sending x over to the other side, in other words, or sending 46 over to the other side. And so I get 46 sine 60 over 64. These cancel out. And so my end result is sine x is equal to 46 sine 60 over 64. And if I want to find my x, my angle, I get inverse sine of that whole thing, of 46 sine 60 over 64. And so if I do sine 60 equals, divided by 64 equals, times 46 equals, I get 0.622455759. I'm going to leave that in my calculator. I'm going to push second function, or you might have a different button for that, like the orange button. Inverse sine of my answer, I get, to round it to one decimal place, I get, so this is rounded here, x is equal to 38.5 degrees, to round to one decimal place, 38.5 degrees. So you'd write a therefore statement. Therefore, the longer chain forms an angle of 38.5 degrees with the ceiling. And that would be your therefore statement. So again, we just had to draw a proper sketch. And once we had that sketch drawn in, it was a little bit easier to solve the problem. So let's start our next word problem. We won't have time to finish it in this video, but we'll at least get it started to hopefully get a sketch in. So two tracking stations, 20 kilometers apart, measure the angles of elevation of a rocket that was launched with a weather satellite. From station A, the angle of elevation is 41, and from station B, it is 75 as shown. What is the altitude of the rocket? To one decimal place. So let's start off by drawing our two stations. Station A, station B. And this is going to be our rocket over here. Point C, big C here. Station A measures an angle of elevation and finds it to be 41 degrees. So that's angle A. Station B also measures an angle of elevation and finds it to be 75 degrees. So obviously my diagram's not to scale. What is the altitude of the rocket? So they're basically asking for what is the height of the rocket. So we're trying to figure out the height of this triangle. When you find the height of the triangle, you know that's a 90-degree angle there. So using this information, we're going to try to figure out what the height of that triangle is. We're not quite done. We do know another measurement. We know that this is 20 kilometers. So using this information and the angles, we're going to try to find x.